Hello guys, my name is John Michael Reyes and we are now on the tutorial for the chapter 9, the transport layer, and we are almost done. Last two chapters, the 10 and 11. Then first, let's try to have a preview about the chapter 9. The chapter 9 is all about the transport layer, data networks, and internet support the human networks by supplying reliable communication between people on a single device. People can use multiple applications and services such as email, the web, and the instant messaging to send messages or retrieve information. Data from each of these applications is packaged, transported, and delivered to the appropriate application on the destination device. The the process described in the OSI transport layer accept the data from the application layer and prepare for it for addressing at the network layer. Excuse me. And a source computer communicates with a receiving computers to decide how to break up data segments, how to make sure of none of the segments get lost, and how to verify all the none of the segments get lost, how to verify all the segments arrive. When thinking about the transport layer, think of the shipping department prepare for a single order of multiple package and delivery. So it is simply said that chapter 9 is all about the transport layer, and it is somewhat all about the TCP and the UDP. TCP and UDP are, I've discussed it in some small way in the other chapters, I think, in the network layer, or I think it's in that, because transport layer and the network layer are associated with each other, and we all know that UDP is somewhat just a faster delivery method, and the TCP is the more reliable one, the guaranteed delivery. Then as you can see in here, when thinking about the transport layer, it is said that think of a shipping department. It is somewhat how we order on Lazada and other stuff. Then as you can see, when we order, in some cases there are some previous way or steps in order for it to deliver the item. Then let's proceed to the another major part of the chapter 9. And hello guys, we're back, and as you can see, we are in the major part of the chapter 9. One of the major part is to differentiate what is TCP and UDP. But first, we all know that TCP services are somewhat just establishing a session, ensure the application is ready to receive. Then same order delivery, it ensures somewhat the segments are responsible into the proper order. It is somewhat for the segments in a sequence number and other stuff. The reliable delivery, it means when some segments are lost, it can be resent or it can accommodate its own. Then the flow control simply ensures that the receiver is able to process the data received. So all the four things that you need to remember is the establishing a connection session, reliable delivery, same order delivery, and flow control. Then the next one is the TCP header. As you can see in here, the TCP header has source port 16-bit, sequence number 32, acknowledge number. It is all the things that it is in the TCP segment. Then server bits, control bits, window size, then checksum, and urgent. Then UDP features. We all know that the UDP means User Datagram Protocol. It is considered as a best effort delivery transport protocol. UDP is a lightweight transport protocol that offers the same data segments and assembly as TCP, but without TCP reliability and flow control. UDP is such a simple protocol that it is usually described in terms of what it does, not compared to TCP. So features of UDP is somewhat data is reconstructed in the order that it is received. Then any segments lost are not resent. Then no session establishment, and does not inform the sender about the resource availability. Somewhat, UDP is just a faster method to send a data or an information to another one. It is somewhat used in the live streaming and other telephony and other stuff. Then let's proceed. And UDP header, they're gonna, as you can see in the UDP header, the difference between the UDP header and the TCP header is somewhat big, because as you can see in the UDP header, there are just bit, source, destination, length, checksum, and other stuff. It is somewhat just a what can I say about that? UDP is a stateless protocol, meaning neither the client nor the server is obligated to keep track of the state of communication session. Is reliability is required when using UDP as a transport protocol. It must be handled by another application. Then, as you can see in here, multiple separate conversation. As you can see in electronic mails, there will be 110 ports. In HTML, there will be 80. Then internet chat will be 531. Then port numbers, we all know that there are source port and the destination port. The source port are dynamically generated by sending devices to identify the conversation between two devices, and the destination port is simply the segment to tell the destination server what service is being requested. Then socket pairs, they are somewhat just a source and destination port are placed within the segment. The segment are then encapsulated. As you can see in here, these are the steps. Then let's proceed. Port numbers groups. The well-known ports are 0 to 1023, and the registered ports are 1024 to port 49,151. Then the dynamic or private ports will be 49,152 to 65,535. And as you can see in here, there are some ports and other stuff. The nets.command is simply explain the connection that can post will attempt to resolve the IP address to domain name and port numbers and to well-known applications. Then these are activity. As you can see, we are just gonna put the characteristic of the TCP and the UDP in place. So less overhead. We all know that UDP is a less overhead than fast transmission requirements. It is somewhat UDP because all UDP are fast, no acknowledgement of recipient. There would be UDP again. Guaranteed delivery, it would go to TCP because of, we all know that TCP can guarantee a delivery and the recent order delivery. Why order delivery? Because we all know that TCP segments its packets and it resent. Then connectionless, there would be UDP. Then sequence message and segments, that would be TCP again because of the sequence or the segments. Then no order delivery, that would be UDP, and those two is TCP because as you can see, flow control and session establishment is for TCP. Then let's check. As you can see, all the answers are correct, and it is pretty much simple from I've said earlier in the chapter. Then let's go to another one, major topic. Hello guys, we're back on the one of the major topics of the chapter 9 would be the TCP connection establishment. And as you can see in here, the first one would be a TCP connection established is in 3 steps. The first one is initiating client request. Then as you can see in here, that the step 2 will be just it will synchronize, then synchronize again. Then after the server acknowledge the client server client communication, it will request an acknowledgement for then after that the initiating client acknowledge the server client communication. Then that's all. It's so simple, pretty simple. Then this the TCP session termination. Then as you can see in here, TCP session termination is fin flag, and there's an acknowledgement segment and other stuff. Then first is when the client has no more data to send in the stream, it sends a fin flag set. Then as you can see, it sends, then the server sends an acknowledgement to acknowledge this recipient of the fin to terminate. Then after that, the server sends a fin flag in order to terminate the session. Then the client's response will respond with the acknowledgement in order to acknowledge the fin flag server. Then the termination will be complete. As you can see in here, the urge is urgent, up is acknowledgement, PSH is push, then RST is reset, then sync is synchronized, then fin is for finish or no more data from sender. Then refer that template 6. Then as you can see in here, this is a termination process. So first it will be send a fin, then after that it will be a this send and syn up, then another syn up, then after that is up. Then let's check. As you can see, it is pretty easy because it is somewhat, you have context clues and other stuff as you can see in here. Then in the termination process it would be fin, then after that it will acknowledge, then it would send an acknowledgement, then fin, then another fin, then after that it would acknowledge, then acknowledge. As you can see, as I've learned, this is for the client response with an acknowledge the fin from the server. Then let's check. As you can see, it's all correct. It is somewhat pretty simple also. Then let's try to see another major topic of chapter 9. And hello guys, I'm back. Then this is somewhat also one of the major topic of chapter 9, application that use TCP and UDP. But first, as you can see, these are the application that use TCP. We all know that TCP always have a guaranteed delivery and other stuff, and segments and flow control and session establishment and other stuff. Then as you can see in here, these are the sessions or protocols that uses TCP. Then applications that use the UDP is somewhat, these are the characteristic: live video and multimedia application, systems, simple request and reply application, then application that handles reliability and other stuff, as you can see, TFTP, SMTP, DNS, DHCP, UDP, and IPVT, somewhat just like that. Then let's drag, then HTTP would be in TCP, this SMTP is in here. Then first let's fill up the TCP, then FTP, then Telnet. Then in the UDP it would be VoIP, then IPTV, then the DHCP because of the server. Then I think TFTP is in here. Then in both is NMTP and DNS. And as you can see, it is all correct, and that's all for the chapter 9 tutorial. Then goodbye.